Now, you all have used 3D printer at some point to create some interesting structures, not only in your science project, but maybe architecture, just a little bit of a template that will later be used on a larger scale. And of course, it's really brilliant to be able to have that intermediate, high school, and high school specifically. We do have a 3D printer, and some of our teachers are really taking advantage of this particular tool by building incredible structures, guiding students through this use, and of course the freedom in terms of that creativity that students can actually engage with this tool physically. Now, in terms of the technology of 3D printing, it is stated that it is using forces of light and heat to create objects. But now there is a new technology that is brought up by a specific researchers in Concordia, and this here is a fantastic, according to this article, breakthrough in 3D printing. And this here is not focusing on forces and heat, but rather an interesting property, which is sound. And you might be wondering, how is it able to use sound to go through structures that ordinarily forces and heat cannot be able to go through? And this technology here, according to the description here, says that researchers here have discovered how to do it with ultrasound waves, that is known as direct sound printing. So this is really fantastic in terms of how ultrasound that we know of, mainly in terms of checking out organs, or for example pregnancy, the development of babies, can be actually taken advantage of when it comes to 3D printing various objects, or most importantly not only large objects, like for example this particular article talking about planes. Maybe if there's a damage on a plane or dent, how can they recreate that particular damage to fill it out using 3D printing, or most importantly the human body. So this is actually fantastic when it comes to not only using it in terms of industrial scale, but also medically speaking. And so in here it says the use of sound wave enables objects to be printed in hard to reach spaces, such as the interior of airplane as stated previously, and even inside the human body. Now, in addition, this article talks about the process by which 3D printing works, and this here is known as cavitation. It says here that cavitation occurs when a substance is stimulated by force, in this case sound waves, and a small bubbles begin to form. And now, as an engineer, according to this particular researcher, we have thought that cavitation is bad. In this case, it is necessary. The vital component is to produce bubbles using sound waves, then drive the reaction in a path that actually creates an object at the end. Now, there is an image that actually illustrates how this process works, and in here we have a driver system that is connected to not only the computer but also a 3D manipulator. And on the other hand, there is a printing head that is attached to the driving system, and there is a special material here that is called a material injection that is injected into a specific muscle cell. And what we have here, or specifically a muscle tissue, and this here shows how once you eject this material to this specific target site, which researchers call this area the ultra active microreactor, then we have the driving system to have the printing head to release a matching medium into this target material injection that has that material in it. And so this here shows how this works, and the rendering of how direct sound printing could work inside the body is illustrated in this particular image. Now, this article points to how this will play a huge role in the medical field when it comes to creating model of different body parts. And it says here that with the use of this can also help in terms of teaching or help educate patients prepare for surgeries. And so this direct sound printing could be used for something like inserting a medical device into a patient's body without needing to break the skin. And according to this engineer professor, and this here shows that it confirms just how much the technology is needed in this particular non-invasive, let's say, process. And this technology can do something that is far can't be done with other technologies. So it is important for us how we shape it into real products and future applications. So it's really fascinating to see this particular machine in action. I'm really curious as to how this year is going to go through series of research and how it's going to be unique, definitely, for different patients, and it's not just something that we standardized for all patients, because it depends on what particular problems that specific patients might have, depends on what type of injuries that some patients might actually have, and being able to have this type of system here that is specific for different cases or injuries or specific parts that needs to be replaced is really a fantastic way of building 3D materials in here. And also, most importantly, what type of materials would they be using in here for this particular form of creation of new parts to be created? Because what they have to do now is figure out what particular model they need to create, and then find that particular shape and design that best matches that particular person's needs. So a durable material is really incredible, and this here is going to be a fantastic way to see the future of this particular device here. 3D printing is here to stay for sure, starting off with just being more industrial scale, like for example engineering, to something much more practical, which is mainly in the medical field, where there is not too much stigma attached to some things like light and lasers, because that tends to scare a lot of patients away. But when you introduce a term like ultrasound, means of creating materials, that is a little bit much more user friendly, because they are familiar with ultrasound in terms of monitoring the development of babies in the womb. So really fantastic stuff in here. Let's know your thought about this in the comment section down below. By that way, we can talk to you all soon. Stay smart as always, and believe in yourself.